For question 5, we have another situation where we're looking for the average rate of change from 3 to some unknown endpoint. So we're just going to use the formula for average rate of change. So I need here, the function is 1 over x, so I need f of c minus f of 3 over c minus 3. And f of c is going to be 1 over c, and f of 3 is going to be 1/3 over c minus 3. Now, let's clean this up a little bit, get rid of the complex fractions. So we'll multiply top and bottom by 3c, which is going to give us 3 minus c over 3c times c minus 3. And one thing you remember about factoring is that you can factor a -1 out of the top over 3c, c minus 3. So this is going to simplify into -1 over 3c. So there's a little formula for the average rate of change of this function, right, this function, between 3 and some endpoint. And let's just look at what this looks like. Again, you should know what these functions look like. So 1 over x is a rational function, and you know that. And we're going between 3 and some other endpoint, right, some c somewhere to the right of this. So if c happens to be 4, right, if c happens to be 4, I'm not going to go through this whole thing. I'm just going to plug 4 in for my c value. So that's going to give me -1/12. And that seems kind of reasonable. If we're going between 3 and 3.5, again, my c value now is 3.5. So this is going to be -1 over 3 times 3.5 is 10.5. In other words, -2 over 21. Okay, if we're going from 3 to 3.1, this is going to be -1 over 9.3. Okay, over here this is going to be -1 over 9.03. Over here this is going to be -1 over 9.003. So it seems as though as c gets closer and closer and closer to 3, as this interval gets smaller and smaller and smaller, the average rate of change is getting closer and closer to -1/9. And here's really what we're saying. At x is equal to 3, if you were going to draw in a line that just skims that, the interval is so teeny, it almost looks like we're intersecting this function in one point. The slope of that line would be -1/9.